Welcome, and I hope you enjoyed Deborah's session. It was very interesting to get a very different perspective on Oracle applications. I'm not going to be talking about APIs directly today, but I'm going to be talking about some ideas that touch upon a common theme of that APIs try to solve. But today's session is about FluentD. And what that means to Oracle and how we can use FluentD and related technologies to get and control some of our logs a bit more effectively and solve some of the real challenges of monitoring modern solutions. So let's get started. And I'll introduce myself. So very quickly, I am a blogger. I'm an author of a couple of books, including something that Deborah mentioned earlier, which is Oracle Integration Cloud. But I'm coming at it a lot more from a technical perspective rather than an end user understanding of it. I work for Capgemini in the UK, which means that unfortunately we are very travel restricted at the moment. So as much as I'd love to be out in Croatia at the moment, travel's limited somewhat. So I hope you'll appreciate and get some value from a remote demo and presentation. So the UK team is a multi-award winning team over the last few years. We've been very successful and developed some really interesting solutions for our customers. Co-op being one of them that you may well have seen Oracle promoting as a story. If you want to know more about what about FluentD and monitoring in general, then the only thing you need to take note of is my domain, which is mp3monster.org. And I'm not going to explain why it's that today. It's a long story, but I put all my presentations there, lots of extra stuff and related material. I do a lot of writing in addition to books. I help with a meetup in London, which I'm hoping next year we'll see back to a physical environment and talking. And if you're really interested in FluentD and some of the stuff that I'm going to be touching on today, then we are in the last phases of releasing a book on the subject. So, you know, go have a look. As I say, I work for Capgemini. I'm not going to spend too much time on here. We're a very large system integrator now with global operations, which means that we get quite a broad challenge, and the UK is one of the sort of Oracle powerhouses in Europe, although we've got Oracle teams all the way through Europe, and I think they're pretty much all recruiting. I know we are in the UK. So let's get on to the real value of this, and this is about trying to understand and get the value out of monitoring and log analytics as an aspect of that. And one of the things I try to do is just step back a moment and think about, what does that mean? What do I want to do when I am talking about monitoring? And the easiest way to do that is just to go look at the dictionary, forget all the technology and all the vendors and things like that. What do we mean when we talk about monitoring? And you can see here that it's about understanding what is going on, and particularly over time, right? Which is the important thing to understand, events over time. And the more funky terminology that we tend to see these days is observability, or to observe. So I went and looked at that, and it was like, well, it's essentially the same point. You know, what is happening over time, and what can we learn about what's happening in our environment? Now, that's great. So let's start to bring a little bit more real-world practicality to it, because now we can start to appreciate what we might be trying to look at and examine. And there's been quite a bit of development, particularly through sort of cloud-native development and hyperscaling, of thinking around this, because the volumes and scale of logging now could be so much more substantial. So there are a couple of ideas, and the one that I particularly find effective in conversations is the 3 pillars of observability, which came around, I think it came from Google, I forget at the moment. But what they said is basically your monitoring will cover 3 different ways of looking at things. Numerical monitoring. So you're going to be looking at sampling of your CPU utilization, your disk utilization. That could be the number of transactions per second that you're processing, and things like that. And you will represent and monitor those quite often in a very visual graph-like model. Then logs and monitoring can cover logging, and there is a lot of textual-based stuff that comes all the way from the operating system in the form of SNMP traps, and that can be on your network infrastructure as well, through to applications, and even possibly into business analytics. And then we have traces. Traces are effectively trying to address the logging, given our highly distributed mechanisms, the fact that we've evolved the way we do parallelization and high performance, not just to spin up a new web server and do thread management, but through Node.js, where you are running a single thread and you're constantly context switching, which creates some interesting challenges in terms of now trying to identify which transaction or which context your technology is running at that moment. And we can lay these different types of measure, if you like, onto different views of our end-to-end solutions. So as you can see here, if we talk about hosting and our infrastructure, we are going to see a lot of metrics. Yeah, which traditionally anybody, if you're an infrastructure person or possibly a DBA, you are probably going to be looking at a heavy amount of numerical information. How much CPU, how much memory, how much disk space, how long are my queries taking, and so on. But you are going to get things like logs as well. That shifts a little bit as we move into our virtualization and particularly containerization. You know, we now got an abstraction layer generating more textual information about what it's up to. If you look at under the hood of Kubernetes, it generates a lot of textual information that it's log rotating. And of course, where a lot of us look at monitoring from the application space, and again, we move down a bit with the pure numerics to log events to actually understand what our application is doing and is it behaving properly, and so on. And then, of course, depending on the tech stack, we might have to move into pure trace. And of course, business application monitoring, which is more the business user, still interested in the metrics. They're still interested in tracking how a particular customer transaction may be flowing through the environment. And they still want to know, are they pushing through with enough throughput of customer orders to be okay, or are they generating a backlog of customer orders and things like that. And of course, then on top of that, we need to understand our capacity. We're in the world of cloud and dynamically scaling our solutions more and more to make them operate very cost efficiently, so we aren't running compute if we don't want or don't need those servers running. We are also got to be so much more security aware these days. Not just because of general hacking and malware, but we are putting so much sensitive data through our environments, and that grows every day. So the application logs, one of the classic ones I've dealt with or encountered in both engagements and even talking with my own team from time to time is, why do we need to log? So some people will use the cost overhead of logging as a reason not to do it. Others are just, my code's fine. Why do I need to log? Well, we're deploying software into different environments, so that can create unexpected errors. So your application just logging to say, this is what I've done, I'm running happily, I haven't got any problems, is still valuable. Looking for performance issues, obviously slow queries and things like that. For security, we need to know who did what and when, and things like that, so that we can attribute and identify abuse of our environments and our systems if necessary. And of course, the bottom line is we need to try and get a holistic picture so that we can try and see cause and effect. If we've got 10 different tools when we're trying to do monitoring, then it's going to get very difficult to work out cause and effect. Trying to sign into or look at many container images, for example, running in a Kubernetes environment because it's scaled out is going to be quite hard. So you need to try and think about harmonization of it. And of course, all of this ultimately is back to what is our business trying to achieve, and can we make the monitoring effective to the business? Nobody's going to pay for monitoring for the fun of it. We've got to be able to potentially align and defend why we're doing the monitoring back to the business goal. So business goal is you want 24/7, so we must understand when the system is struggling under load, or understand if there's any performance user experience degradation over that period. They are the business needs, is they don't want user experience degradation. They want the system running around the clock. And of course, as I've mentioned a few times now, the technologies that we are using are driving sheer complexity in the monitoring space. Back in the 50s and 60s, we ran a single COBOL application. Today, we are multi-threaded with virtualization, containerization, cloud. You've got different approaches to parallelization in the application through the likes of Node.js fees, more traditional thread management. And it's just got more and more complicated. So what does FluentD mean to Oracle? So I've been talking about FluentD and not Oracle monitoring or the traditional enterprise manager style tools that help us do some of this. Well, the reason for it is FluentD is a CNCF project. Oracle's Verrazano project, which is their application platform for multi-cloud and hybrid use cases. So if you want to be able to build an application and deploy it anywhere, not just Oracle, but Azure, AWS, in your own data center, Oracle have been developing this offering called Verrazano. And Verrazano uses a lot of the cloud native foundation technologies, including FluentD in there. So behind the scenes, Verrazano will use FluentD to orchestrate and manage your logs so that you can get it to a single view and inject it into the Oracle observability platform in the cloud, or it could equally get pumped into your preferred monitoring tool. And that's the beauty of CNCF's approaches. They're vendor agnostic, and FluentD, as a result, is vendor agnostic. And not only that, many vendors have developed integrations into FluentD. You won't be surprised to hear that underneath the Oracle Cloud Monitoring are open source and CNCF-driven technologies, either directly or based on. And FluentD is working under the hood of Oracle Cloud Monitoring. And they support integration directly into FluentD. So if you can connect to FluentD, you can capture and monitor activity with just about anything. And I don't say that lightly. So I've talked about it. I've said why it's important. Let me actually show you what it is and its value proposition. So it's a highly pluggable engine with a goal to try and capturing primarily log data. That's where its strength is. And it is very extensible. And what we can do with it is capture all of this log data as inputs from log files, from sockets, from operating systems, from application formats such as Log4j if you're a Java developer. You can integrate it directly to your Python and Node and so many other things. And then, of course, we want to get that log data somewhere. So you might be using Prometheus and Grafana to visualize some of your log information. That's fine. FluentD can abstract the information. For example, if there's a log message giving you your percentage performance or utilization, we can extract that percentage number and feed that into Prometheus, and that gives you the ability to look at things over time. Back to my opening point about the observability. It can feed just about any file format you like, databases and NoSQL databases, event streams such as Kafka and Kinesis, MQTT, JMS. As you can imagine, quite a lot there. We can get clever. One of the things that historically people tend to do with logs is just aggregate them into a big data repository and then just do searching on it. That's very much behind the curve. You're looking for error reports that have happened some time ago, 5, 10 minutes, maybe hours ago. What we can do with FluentD now, because it is constantly picking up these events, we can put into it some intelligence that says, okay, this event is significant, and if I tell someone now about it, we can get in there and do something about it before it becomes a major problem. You know, if you've got a log event saying my disk space is down to 10% available, you know that that's going to be impacting your performance. And if you're chewing through disk space rapidly, you want to get in there and either extend your disk storage for your application dynamically, or go and do some purging of files. Or if there's no apparent reason for that to occur, go and start the investigation before it runs out of storage, because that's going to crash your application more likely than not. And crashing your application mid-transaction means corrupted data, it affects your business, and so on and so forth. We can format the data in many, many different ways, and that means that we can use different tools to process the events that are coming through FluentD. As I mentioned, we can translate it into a structure that Prometheus can handle. We can turn it into a structure that Elasticsearch can handle if you want to use Elasticsearch. We can filter out, which is the basis of the example I explained. You know, filtering and looking for very specific log events that tell us something important or urgent. We can parse them, so we can actually start to interpret and extract meaning out of the log events, because it's meaning that allows you to do things. We can buffer and cache things up. That gives us better performance with handling our logs and transmission. And we can just bulk store it for future records. If you're just trying to filter out your audit trail of users from a stream of logs, then you can do that. And you can stitch that together by taking the auditing from lots of different applications or components that meet your solution end to end. So it's very, very flexible. And if in the unlikely event you can't find a plugin that will deliver what you need, you can actually go and write your own one, and it isn't difficult. So if you've got one of those legacy systems with an esoteric logging format or audit format that you want to capture, you know, people are going to say you can't change the logging of the legacy system. So you can write a custom adapter, use that into your FluentD setup, and it can then start monitoring that legacy system without any change impact, which is a real benefit. All log events in FluentD come with a solid standard structure. Everything has a tag, has a timestamp, because we're looking at time-based events, and a record, and that record can be completely unstructured through to fully structured data. What we need to do with our monitoring, whether that's a log from an application or pulling an event off the operating system, is we need to capture it, structure it, and get it to the right place, and then analyze and aggregate, because to get your time perspective, you're going to need to bring multiple points of data together and do some analysis. Now, as you can see here, FluentD's absolute sweet spot is the left half of this path. It does support a little bit of the right-hand side, but not much. The right-hand side, you do achieve these kinds of activities in your monitoring and operations processes by using FluentD to leverage tools that are absolutely brilliant at this. There are other tools that are far, far better at driving notifications than FluentD, Slack, for example, or you might want to integrate it more tightly into your OpenOffice or PagerDuty or something else like that. Data visualization, well, you've got BI tools out there are phenomenal for data visualization. So why compete with it? Let's focus on getting that data out of the environment, working out what's important and what it means, and then routing it to the right place. So one of the classic situations, and I'm dealing with it with a customer at the moment, is in sort of medium and large organizations, the security team have their own preferred tools and they want to use that tool. Your ops team that are just looking after the application and trying to keep it up and running and making sure there aren't any issues, and keeping things healthy, managing updates and things like that, they're going to be potentially using a different tool. That creates some challenges. So what we can do with FluentD is now say, okay, well, these messages are important to ops, and these messages are important to the security team, and these messages are important to both, and therefore send it to their tools. So now you can use end tools that are absolutely optimal for a particular task. You know, many people use Splunk because of its strength on security. Others use Elasticsearch. App developers typically will be using Elasticsearch because you want to trawl through what's happened over time. And I mentioned Elasticsearch, which leads me very nicely into this. If you're on the development side of things, there's a chance you've heard of the Elastic Stack, or the ELK stack as it's sometimes referred to, which is here. Using Logstash or Beats to collect the data, Elasticsearch as the aggregation point, and Kibana as the visualization and analysis tool. But there is a growing adoption of a slight variation of this, because FluentD offers a number of benefits over Logstash, and that's to use what's called EFK. So Elasticsearch, without a doubt, is an exceptionally good tool, and great for doing textual searching across lots and lots of data, but it is hard to set up and tune up. And then Kibana, you know, to do the visualization and the representation. But people are moving or considering the EFK stack because FluentD is more pluggable. It has a slightly better footprint, and as a result means it can capture more and filter slightly more effectively than Logstash. That's not to say Logstash is a bad tool. It's just if you look at the stats, FluentD has the edge to it. So very quickly, the FluentD process works by defining match rules or directives which are processed in a particular way. And I'll show you a real config in a minute. So I've got an illustration here of a setup that I use to help convey the capabilities of what we can do. On the left-hand side, I might have 2 microservices generating log files, and I can feed those into FluentD, and then I'm going to use FluentD to pump the a subset of the logs to a local log file that's easy to access. And then I'm going to collect significant events from several sources and feed it to a single central point, which is then going to talk to Slack and send significant log events to a dashboard screen. If you know, ops teams quite often have what they call a warboard, which is showing significant events being coming through the environment. Of course, I can scale this up just by redeploying the configuration from my first FluentD on the left here, and then I can even scale the center if I need more nodes to compute all the inbound messages. And then, of course, we've got to pass that through the network so we can transmit through the network. This is not a shared file model or anything like that. And I could, of course, tap into that shared network feed and go, all right, I need some more data, the same data or a subset of the data, as I was saying, to go to my visualization and notification tools used by potentially other teams. But I'm not going to show that extra leg today. I'm going to focus on this, right? This is FluentD configuration. It's a slight variation on YAML and XML, which takes a little bit of getting used to, but once you understand the when to use the angle brackets for the just YAML-like name values, it becomes very quick, very easy to understand. And you can see the configuration is very, very simple. In my example, I'm just tracking log files. So I've just set up a plugin called Tail and told it where the log file is, and to therefore pass it on. And I've told it the data is going to be native JSON. And you can see I'm putting one of those feeds into the pipeline and the other one is getting immediately forwarded. And there you can see the fact that I can do a little bit of transformation on the log event if I need to get more meaning out of it or want to extract just a subset of values out of the event. And here we go. So I mentioned that it's all being pushed to a file. So there's my file, and I'm using a little bit of formatting to be applied to the file. And of course, I've just pointed to my other FluentD node on my local machine, which means that, you know, because these FluentD nodes are so small, I could run many of them on my laptop to test out and develop configurations if I want. But I'm just directing everything to my local server. Then here's the other server. Very, very simple in its setup. You can see I'm collecting from the network using a plugin called Forward. Forward is rather clever because it compresses the data somewhat whilst it's been transmitted over the network. And it then brings it into a common process called Common. And I'm filtering out and only looking for messages referencing computer or on computer, because it could be a upper or lowercase c. And in this case, I'm using the a regex style filter for that, but there are quite a few different types of filter in addition to regex. And then I've got my parameters to talk to Slack. Here, to demonstrate my little use case, I need some log simulators rather than running up big applications. There's a log simulator tool that I've been developing, and it can interpret log files and replay them, doing a time shift if necessary and things like that. So I've got log simulators generating the source log files for FluentD to follow. So as it writes to the file, FluentD will pick it up and send the events through the pipeline. Now, I was going to run this demo, but I made two mistakes. One was to not say anything to the great demo gods out there and ask them to look nicely upon my demo. So it didn't have the fatal live demo crash. And I last night had a spark of inspiration on how I could improve my log simulator. And when I came to quickly run it up this morning, discovered I'd broken it. And without time to sort of safely go back and make sure it fully works, I'm showing you here an example. It does work after a fashion, so that I can show you the processes all running on my screen if we bring them in. So what we've got here is two FluentD nodes, and I've set them to be fairly chatty. And let me show you. What you can see here is it's spewing out to the console all the log events that it's receiving. Yeah, and you can see it's talked about transforming one of the feeds. And we can see here the timestamp, the origin, and the data that I've fed it. So there you go. If I go back far enough, and we can see it powering up here, and it's just showing me what it's got in terms of a complete configuration. And then down here is so that's node 2, that's the central one. And here is node 1, which is my source. And you can see again, it's powered up, and this is a lot less chatty, so it's not showing too much about what's coming through. And you can see it's talking about what it's doing. So I've not got a particular implementation of the regex that is deployed, saying, okay, you haven't installed this extra fast one, so we're going to use this one instead. Okay, and then over here, this is my log simulator, and this was generating log files, which I should be able to show you if I go into this folder. And you can see it's generating log files. And so that's the log file it's reading from. These are tracker files, so if FluentD was ever to stop, it can recover where it left off. And then, as I said, I was writing out to a file, and you can see here it's writing the log files out and using a log rotation configuration as well. And if I look at that, here we go. And that was what I was writing. And the outcome, if I just bring my Slack into play, is for my setup. Here's my Slack. And you can see I did run it this morning, but the fault I created is not respecting the timing replay. So it was just blatting everything through in milliseconds, which meant that when I was holding up, so I was in the configuration have set the flow to only have so many log events per minute being sent to FluentD, meant that most of the events that it was sending were happening in very short time. So, but you can see if we look at this, the log events have got references to computer in every one of them. So it's filtering it out, because there are lines that are definitely not based on that. So that was the demo, and that's a screenshot. So let me carry on. One of the things that people tend to overlook quite quickly, and this is a nicety of working with Oracle Cloud particularly. I created a little example use case where we're multi-cloud, and logs are voluminous and they consume a lot of data. Yes, you can compress them, but if you just chuck everything in, you've got a very chatty application. Over time, you could be passing a lot of data over the network. And if you're running your ops in analytics in one place, you obviously want to be pumping all the logs, or at least some of the logs. And yeah, 1 terabyte coming out of Azure. If I was running a Splunk or something like that, or an Elasticsearch on-prem, 1 terabyte, that's $87. Okay, not huge amounts in the grand scheme of things, but that racks up very quickly. You know, AWS is 85, Google is 85, and you've probably heard this, but it's striking when you look at it like this. $8.5 for a terabyte out of Oracle in comparison, which was just absolutely amazing. Of course, you will probably have multiple flows as well, not just going to your central system, but going cloud to cloud potentially, and so on. And that's going to carry on chewing up traffic. And if you're tracking your VCN flow logs, for example, out of Oracle, That's a lot of data about what's happening in your network being generated. So one of the things that we can do with FluentD is to go, okay, actually, we will put FluentD in our environments, and we'll store a full unfiltered set locally. So if we need everything, we have a means to go find it. But anything that is genuinely significant, we will let flow through. And that's just a simple application, FluentD applying that a filtration for you. Now, all of a sudden, all those WebLogic server log messages where it's just saying, yep, I'm rechecking, rebalancing the number of threads I'm running in my pool. I'm happy that it's churning out all the time. Well, you can filter those out, but you can keep them just to make sure, if you want to double check that everything is fine in one place without needing to resort to signing into one or many servers. So that's a simple model, a very simple application of FluentD to save you some cost. So I'm going to just show you a real-world solution and some deployment and scaling options, because one of these things that I've mentioned many times now is the challenges of scaling and deployment. So we can deal with highly distributed solutions here. The FluentD footprint is tiny; it's tens of K. So we could run it like this, where we've got traditional servers. They might be virtual. Across the top, hosting parts of our application, and they are pulling out the significant events from those logs, which are being aggregated on our mid-tier, potentially also filtering and looking for alertable events for us, and also putting it all into an analytics platform, so you can start to do things like looking for performance issues over prolonged periods. Am I slow? Is my system slowly degrading its performance over days or weeks, for example? Or that could easily be a conventional, or I say conventional, a Kubernetes style environment with pods. And you've got different ways of deploying in Kubernetes. You can use just monitoring the Kubernetes logs, or you can, which will aggregate any standard out and standard error coming from the pods. You can use Sidecar as a pattern, which is one that we highly recommend, which is this one. Or you can deploy FluentD or its little brother FluentBit, which is just a subset of FluentD, and just deploy that in your container. And this is what we produced for a customer. They were multi-cloud, including on-prem. Most of their applications were Java-based. Not a few that we were seeing weren't. They were moving towards building and using microservice techniques. So they were wanting to use open tracing. So we were collecting the open trace data, as well as letting that go through to the dedicated open tracing tools. We aggregated that and routed it through from the different environments. They were using Splunk for their security. Their ops teams were preferring to use Elasticsearch, Prometheus, and Kibana. So we were feeding to those, and there were different teams running their own deployments of those. So we were aggregating to a central one as well. So there was an end-to-end picture of what was going on, as well as supporting different ops teams that were responsible for different subsystems in the solution. And then, of course, we whacked in a couple of Slack notifications that really was to support the pilot and beta use cases, where we could react very, very quickly to any issue whilst we were in pilot. and determine the root cause and get it resolved quickly. And as a result, we wanted Slack for those use cases. And that meant Slack, we'd set it up so Slack would ping in a particular Slack channel if it found a particular type of event. So it was going to the right people. So lots of different routing filtration in there. And you can see across the bottom, I've overlaid that evolution or timeline of data in a monitoring environment, starting at the source over here on the left, the structure and the route, which was actually multiple, wasn't a single FluentD node, it was multiple nodes with secondary nodes in a standby position. So if anyone, one of the source systems couldn't find the primary, it would automatically start sending logs to the secondary. We would structure and route through there. And then you can see these systems are pretty much either aggregate and analyze or visualize through Grafana, Kibana, Slack, and then notify and alert. So some exceptions, we just said, okay, we're going to raise a JIRA ticket. If it was a mature component in the system end to end, and it threw an error, that's probably because we've introduced some uncertainty elsewhere, and we'll track that uncertainty elsewhere and we'll create a JIRA ticket just in case there's been a drop transaction, so that the support team's got have a dedicated ticket to go and look at and report their findings against. And that's it. So I hope you found that useful and insightful. If there were any questions, I'm more than happy to take them now, or you can always reach out to me through the social media channels. Slack, sorry, not Slack. I've got Slack on the brain at the moment. Twitter and LinkedIn, and comment on the blog and things like that.